A system of equations is basically a set of equations that work together for the same problem. That's all a system is. I can have the parts of a car all laid out in my classroom, all separated out, even though they all make up the whole car. Is that a system? No, a car won't work. When I put them together, it becomes a system. In fact, it becomes all sorts of systems. Your ignition system, exhaust system, and so forth. Well, system of equation is kind of the same thing. There are two or more equations that work together in the same problem. Okay, if I just have one equation, that's not a system, it's just a standalone equation. For example, if I give you the equation y is equal to 2x plus 3, oops, I'm supposed to say 2x plus 3, then it looks something like this. You know the slope is 2, up 2 over 1, up 2 over 1. You know the y-intercept is 3 because I've got the mx plus b there. The 3 is right there. Okay, and you say, well, what's the solution to this? Well, it depends what x is. If I say x is 10, you know, then y is this value over here. If I say x is 0, then y is 3. If I say x is negative 1.5, then y is 0. So it all depends on what x is. Y is always dependent on what x is. So that's why it's called the dependent variable, and x is the independent variable. But now when I put in a different equation, say y is equal to, give it a negative slope, negative 5x minus 4, then that looks like this. And I can say, what's the solution to this line all by itself? Well, it could be any point along this line is the solution. Okay, but if they are working together, if that is a system of equations, then the solution is where they intersect. Let me close in here, right here. The solution is right there. X is negative 1 and y is positive 1. That's how a system works. Okay, there are three possibilities for doing a system of solutions as far as what the solution is. And I'll just draw for the first one. So if I have two lines, two or more, but for algebra 1 it's only 2. If I have two lines, then wherever they intersect is a solution. It doesn't matter where those lines are. They could be like this. Wherever they intersect is the solution. Okay, so what do you notice about these lines that I drew? Their slopes are different. Okay, their slopes are different. They will intersect at some point. It could be on the graph paper you have. It could be, you know, x equals 10,000, y equals 10 million. Doesn't matter. If their slopes are different, they will intersect somewhere. And that means that's where the solution to that system is. Now, when is there no solution? Okay, you have no solution if you have two lines that are parallel, basically with the same slope. So I'm going to give you y is equal to 2x plus 3 again. And then it has to be the same slope. Y is equal to 2x minus 1. Now, even though they have different y-intercepts, this is plus 3 and this is minus 1, let me expand out a little bit. Okay, those lines are parallel because they have the same slope. The slope is positive 2. They will never intersect. Therefore, there is no solution. Even though those equations might work together in the same system, there is no solution because they do not intersect. So that's the second option. Third option is, see if we can make this work right here. y equals 2x plus 3. Now, what I have is two lines, but one's on top of the other, okay? So, and sometimes you might see it in different forms. You might see it something like this. You might see 3x minus 2y is equal to 6, and then 6x minus 4y is equal to 12. Okay, notice that this one is exactly double this one. And when you simplify it out and put it in the slope-intercept form, it turns out that those are two lines. Those are the same. One line is right on top of the other. Okay, and you think, well, what's the solution? Well, no matter what point I pick, it's a solution. Come on. Of course, I have to make an announcement in the middle of my video. But anyway, when you have two lines, one's on top of the other, then there are infinite solutions, because no matter where I put a point, it's on both lines. So it intersects forever in both directions. So the infinite solutions. So in summary, when you have a system of solutions, there's either one solution where the slopes are different, you have zero solutions, the slope is the same, but the y-intercept is different. And then you have infinite solutions where the slope, slope is the same, and the y-intercept is the same. In other words, it's basically the same line. Okay, so those are the three options. And the one we like to do, where it gives just one solution, is when you have two lines where the slopes are different. You will only get one solution. But just be aware that these other two options exist. You just have to look. If lines are on top of each other, they're infinite solutions. If the lines are parallel, there are zero solutions. And in summary, that's how systems of equations work.